Alright, so let's draw our axis. Okay, so what we do is that, again, let's start at day 0. So what's going to happen here is day 0, and then we have our day 28. And then we have our day 14 roughly in the middle, and day 7, and day 21. So again, the average woman's menstrual cycle is not 28 days, but it's easily divisible by 4 and into weeks. So what we're going to do is draw estrogen. So estrogen, I'm going to abbreviate by putting it as E2. So E2 is estrogen. So what do we start off with that ovarian follicle? We start off with these granulosa cells, right? And they start in a very small primordial follicle. And remember, these granulosa cells produce, what do they produce? Well, they take androgens and they use aromatase to actually convert that androgens into estradiol. So this little granulosa cell is going to secrete estrogen. So we start off with a little estrogen. But what also happens is that you have follicle stimulating hormones. So follicle stimulating hormone is always there to some extent, but we have this follicle stimulating hormone, or FSH. And what follicle stimulating hormone does is that it stimulates these granulosa cells and follicles to grow. So FSH is going to cause these follicles to develop. And what happens when these follicles develop? Yeah, let's draw a little pretty oocyte right here. Actually, let's make the oocyte, since it's very special and very important, let's draw it as gold. This golden little egg, yeah, the golden egg, that's our oocyte right there. Okay, so as this FSH starts to tell the follicles to grow and to develop, hey, we have more granulosa cells. We're going to crank out more estrogen. So that's what happens here. And if we have more estrogen, what happens to the overall levels of estrogens? It starts to increase because our follicles are getting bigger. Bigger follicles means more granulosa cells. More granulosa cells means more estrogens. So what's going to happen is that this follicle is going to continue to develop. FSH is still there in the background. Now you're getting bigger follicles with more granulosa cells. And as this follicle gets bigger, it's going to crank out even more estradiol. So that's what we have here. So as this follicle gets bigger, this estradiol increases, and increases. So the interesting thing is that FSH will increase eventually. So GnRH is always there in the background. So what color should I use for GnRH? I think, oh, I shouldn't have used FSH to make it consistent with the previous picture. I think they used GnRH was green in that picture. Let's just use orange. So GnRH is always in the background. It's also increasing as well. So this is GnRH. And actually it's the pulses. So the pulses actually increase. So it's like one pulse and then a few pulses. And over here starts pulsing like crazy, having a lot of these pulses in GnRH. So what we have to do is think about that hypothalamic pituitary axis. And if you remember our hypothalamic pituitary axis, and you can get another piece of paper, you have the hypothalamus. So and then you have your little pituitary over here. So those are the lobes. Again, this is not the testes. And the hypothalamus is going to release GnRH. And that positively stimulates the pituitary. And then that pituitary is going to release FSH and LH. And that's going to target our ovaries. Which secrete estradiol, and for now let's just add inhibin as well. Now here's the interesting thing. So estradiol does do negative feedback on the hypothalamus and pituitary, so it does apply the brakes here. Now this is why inhibin is a little complicated, but it's actually important. If you look at the graph between FSH and LH, they're not quite the same. So again, FSH and LH, let's rewind a bit. If GnRH increases, which it does as you approach ovulation, FSH and LH will also increase. But do they increase at the same rate? Well, the interesting thing is that maybe I should actually do a switcheroo here, because let's put FSH here and LH over here. Well, the funny thing is that inhibin actually inhibits the pituitary production of FSH. So what happens is that inhibin is kind of like, it doesn't treat FSH and LH fairly. It doesn't apply the brake to LH, but does apply the brake to FSH. Now, what does that mean for our ovarian cycle? Okay, so I'm going to erase GnRH just to make it a little more clear. Okay, so FSH is going to increase because, again, we have GnRH, or maybe I'll just put it as a little dash. Yeah, I'll put it as a little dash, just to say it's in the background and starting stuff. So FSH is going to increase due to GnRH, but since you have inhibin that's blocking FSH, you also have inhibin increasing as well. And why is that? Well, inhibin is going to increase. Why? The funny thing is, if you're stimulating the ovaries with FSH and LH, you're also going to increase inhibin. So inhibin will also increase as you go as the follicles develop. So remember, inhibin is keeping FSH down. It's kind of suppressing that pituitary axis. Now, what about LH? So LH, luteinizing hormone, and I'm running out of colors here. So LH is going to kind of like be along with FSH, but remember that LH is being stimulated by this GnRH down here, right? So with this GnRH over here, it's going to stimulate the production of LH. So LH I'm going to draw as a yellow color. So LH is going to spike as well. So what LH does is that LH is the one that triggers ovulation. So this is why they say ovulation is triggered by an LH surge. So yes, FSH does play a role too, but LH is the dominant one, and it increases at a sharper rate because FSH is being held back by inhibin. LH is free to accumulate. So what LH does is tells this, you have this huge amount of LH over here, and it's going to tell this follicle to rupture. Can I find that previous color? Partial color blindness, don't fail me now. Okay, so now this follicle will rupture. So what's going to happen? Now we're going to have some corona radiata granulosa cells hanging along for the ride. And we have our little egg. So now it's going to release all that fluid. And now we finally have ovulation. Again, it's a little off-center, but should be around midpoint. Now, this luteinizing hormone, it does something special. It converts the follicle into the corpus luteum. So now our follicle is spent, And the interesting thing is now it's going to change. So this follicle is, can I get a better color than that? Maybe something. Well, actually, the corpus luteum, it's called luteum because it's like luteus, or the root word means yellow, so let's just call it yellow. So the corpus luteum, it's spent and no longer has its oocyte because why? It's been ovulated into the uterine tubes. So this corpus luteum, well, the interesting thing is now it switches. Instead of producing estrogen, the granulosa cells of the corpus luteum, they switch from estrogen or estradiol production and make progesterone instead. So they're going to make P4. So progesterone is sometimes abbreviated P4. Actually, can I use another color? Yeah, maybe this color. P4, progesterone. Ah, that's right. I should have put that as estradiol. Catching myself there. All right, back to progesterone. So the interesting, now that we're switching from estrogens to estradiol to progesterone, so estrogens are going to drop. So we do have a start loss, but the interesting thing is that corpus luteum does produce estrogens, but not as much as progesterone. So progesterone, it does start off low here initially. So P4, it starts off pretty low. But once you have ovulation, redraw this part right here. So once you have ovulation and formation of this corpus luteum is going to crank out progesterone. And some estradiol. Again, it's not a complete switch over from estradiol to progesterone. It's just now it's preferring to produce progesterone. So estradiol is going to take a hit, but it does bounce back slightly. Not as much as it did when you were triggering ovulation, but yeah, that's what happens. And luteinizing hormone, that's going to drop. And so is FSH. But now progesterone is going to be dominant. Because why? That corpus luteum is progesterone dominant. It switches gears. Now, as a corpus luteum starts to mature, it starts to degrade and get smaller and smaller. As it gets smaller, it starts producing some progesterone, but not as much. And when it finally becomes the corpus albicans, I'll just draw it as this like little thing right here, it's done. It's not going to produce progesterone, so you don't have progesterone. So what's the overall path of progesterone? Well, progesterone, again, is going to increase as the corpus luteum produces more progesterone, but as it becomes the corpus albicans, it starts producing less and less progesterone, and that's what we have here, a drop in progesterone. And remember that the corpus luteum is still producing some estrogen in the background, so it will have increased, but as it becomes the corpus albicans, it's going to decrease as well. So what about inhibin? So inhibin is very interesting. Inhibin is still there. In fact, it experiences a similar rebound. So inhibin also increases because, again, inhibin is also produced by granulosa cells. The granulosa cells are still here. So, but as that follicle and that former follicle and corpus luteum starts to degrade, it's going to degrade as well. Now, what does that mean for FSH and LH? Well, the thing about FSH and LH is that, let's go back to our axis here. So both P4 progesterone and estradiol, they do negative hit feedback on the hypothalamus and pituitary. But since inhibin is still there, that's also still going to keep FSH pressed down. So inhibin and the increased levels of estradiol and progesterone, these are going to keep LH and FSH levels squashed. Because why? Estradiol puts the brakes on it. So does inhibin. Puts the brakes on FSH and LH. And so does progesterone. Phew, right? So it's very complicated at the view, but this is why it's very important to understand endocrinology. All these hormones affect each other, and what do we have here? Well, again, FSH is triggering the production of and development of the follicles and the development of granulosa cells. Granulosa cells make estrogen or estradiol and inhibin in the first phase, the follicular phase of the ovarian cycle. Once you have that LH surge, again, why? Because that increased inhibin is going to put the brakes more on FSH than LH. The LH surge is going to switch the follicle to the luteal phase. So the luteal phase, what happens? Well, again, now these granulosa cells, they kind of change their specialty. They're like, I'm done with me, or maybe estrogen isn't what I'm into. It's not my mood right now. I'm going to go to more progesterone dominant mood. So the luteal phase is going to produce more progesterone. And we're going to talk about what progesterone does real soon because it's very important. So that progesterone is going to be there, some estrogen as well, but also some inhibin. So that's going to, those progesterones, the steroid hormones, the estradiol and progesterone, it's going to keep, that's going to be the dominant part of the luteal phase. And the inhibin is also going to help to keep FSH down. And the steroid hormones, estradiol and progesterone, they're also going to keep GnRH and LH down as well. Whew. All right, so then let's go back to, so that's how to draw all the hormones of the menstrual cycle. And this becomes very important in what I'm going to talk about very soon. All right, let's go back to our talk. Yeah, so happy little estrogens, steroid hormones, and whatnot.